Hi, 8th graders. Today we're going to talk about section 15.2, chapter 15, section 2 on heat. I've briefly touched on heat before. Okay, remember, heat is the transfer of thermal energy from a warmer object to a cooler object. Okay, we don't go from cold to warm. All right, it's whenever there's warmer molecules with higher kinetic energy that move faster, and they're going to go from the warmer area to the cooler area. All right, heat, we don't see heat. We don't turn the heat up. We turn thermal energy up, and we turn the temperature up, so we get more thermal energy throughout the room or wherever we need that. But heat, basically, I want you to think of heat as a verb. We can't see it. Heat is simply the transfer of thermal energy. It's the transfer. It's a verb. It's moving. It's moving kinetic energy that has a lot of high kinetic energy, molecules that are moving really, really fast. And then those molecules cause the thermal energy to have more. Remember, thermal energy is the total amount of potential and kinetic energy of the molecules, or the particles of the substance. So the more they move, the more thermal energy, in a sense, when we talk about temperature, the average kinetic energy rises. And when that average kinetic energy rises, we say it's warming up. All right, that's the temperature. Heat is just this transfer of thermal energy from one object to the next. And there's three basic ways that that thermal energy can transfer. But before we get to that, really, these are the three big things that we're talking about in this chapter. Heat. Heat is our transfer, okay? Thermal energy is the total amount of our kinetic and potential energy, and then temperature is our average kinetic energy of the molecules. So these are three very distinctly different versions of things that we talk about and we use interchangeably on a daily basis. But scientifically, they are much different in the way and they're described and the way they work. Okay, so how do we transfer heat? There's three ways. By conduction. Conduction is pretty simple. That's touching. When the particles collide with one another, we know that when particles collide, they create friction. Friction, we know, we said, creates heat. All right? So that heat that friction is creating is the transfer of the particles with each other as they're rubbing together, they're touching each other. It's the contact. Okay? It can be, like an example would be an ice cube melting in your hand. Your warm skin, your warm body is much warmer than that ice cube. So when that ice cube's in the palm of your hand, it starts to melt. Why? Because of conduction. Heat is being transferred. Thermal energy is heating the ice cube. So the slower kinetic energy and potential energy molecules of the ice cube are being warmed, if you will, by your hand, where the thermal energy, the total of all the kinetic and potential energies in the molecules of your hand and your ice cube, it's transferring the warmer particles, the ones that are moving faster, to the ice cube. Now they start to move faster, and we know that when we go from a solid to a liquid, our heat thermal energy is rising. If we go back to our phase change chart, we talk about thermal energy down on the bottom. We use the word heat sometimes, okay? Well, thermal energy is increasing. When thermal energy increases, molecules move faster. And that increase in conduction is by basically the molecules touching each other, okay? The second one is radiation. The easiest way to describe radiation through electromagnetic waves, the transfer is on a very hot day, right? You can sometimes look down out towards a field, or more specifically, a roadway, and you'll see like the bending of the waves, or we say, oh, look at that heat radiating coming up from the road. Okay, that's radiation. Okay, when you can see waves of air, sometimes depending if the situation's just right, you can see this thermal energy being transferred through these electromagnetic waves when you see the air, like invisible air, if you will, but you see the waves and it gets all wavy as it's moving up and away from the warmer area or the warmer surface. Okay, that's radiation. Our third one is convection, and that's just when warmer particles, usually in a gas or a liquid, I've got a liquid shown here, where when it warms up, warmer particles tend to rise. Well, when they move from that area where they were warmed, cooler particles fill back in. And those cooler particles, then they gain more thermal energy, warm up, and they go to the top, and we just get a cycle that just keeps going around and around and around until all the particles within that substance reach the same temperature. Okay? So that's what this is. Think of a pot on a stove. All right? So here's our makeshift Bunsen burner, warming up the water at the bottom of the beaker here. Warmer rises, okay? Cooler replaces. So warm air rises, cool replaces where the warm water was, and this cycle just continues over and over and over, okay? It can happen outside in the air. That's how, we can get things to warm up. All right, so our takeaways from section 15.2, heat is the transfer of thermal energy, okay? It's nothing really more than just a verb. It's transferring thermal energy. And how does that transfer happen? One of three ways: conduction, radiation, and convection. 3 ways. Be sure you know each of the 3. Okay? I hope you're all doing well. Continue to work on the work that I put out the other day, and we'll talk to you soon. Stay well.